Hello everyone and welcome to our session. My name is Socrates Kartakis, a Principal Solution Architect for AWS, and I show to most of our customers across EMEA how to productionize either machine learning solutions or generative AI. Today we will show you also the journey to go from idea to production for your Gen AI workloads together with my colleague Alexandra, and also Booking.com with Iran will show us the journey that they took in order to productionize their own applications. What we have prepared for you today is, first of all, we will talk a little bit about MLOps as a brief summary, right? Then we will show you what is the difference between MLOps, FMOps, LLMOps, and then we will jump into the different journeys of the different customers, depending on your needs, etc., of how you productionize generative AI. But let's crack on. As we have seen already, MLOps is the combination of people, process, and technologies to productionize machine learning solutions. And what is the landscape and how it looks like? First of all, we have the platform team who is responsible to create accounts, create the infrastructure, VPCs, networking layers, etc. And then we have the data layer, the data environment. In the data environment, we have the data engineers that they prepare the data, they catalog the data, they ingest the data from other sources, and they make them available to others. Data owners, they share the data with others. Then we have an environment for data scientists to experiment on and to create their own POCs, and whenever they are ready to productionize their use cases, we have data scientists and ML engineers to collaborate together to build models, test the models, and deploy the models for others to use. And the last piece of the puzzle is about ML governance. So we need a centralized place that we are able to assess the performance of the models, to approve which model will go to production, and more or less to see what artifacts and data we used in order to build all these models. And all this is what we have seen so far around MLOps the last 2 years. But how is that different than generative AI, and how we can productionize those? As you already know, the main ingredient for Gen AI is the foundation models, right? These models have been trained based on trillions of data or billions of data to resolve different applications, like text-to-text applications that we know in this domain. We have the large language models, text-to-image, text-to-audio, text-to-video, text-to-whatever will come in the market. Now that we know these basics, let's see the key difference that we have between MLOps and FMOps. MLOps is the combination of people, process, and technologies to productionize machine learning solutions. FMOps is the combination of the same pillars in order to productionize any Gen AI solution of all the different categories that I showed you earlier, like text-to-text, text-to-image, and other categories. LLMOps is a subset of FMOps, and it focuses mostly on the large language models. Okay, let's jump into the differences. I removed a little bit LLMOps not to be that busy. What are the differences? First of all, is about people and process, right? We have providers, fine-tuners, consumers. We have new operations. How you select a model is very critical in the whole life cycle. How you evaluate the model, how you can fully automate everything, how you monitor the model, and of course how you prepare your data and how you deploy the models in order to start using them with a very cost-efficient way. All these differences, they have impact to technology. But let's start with all these domains step by step. Let's start with the user types, first of all. We have providers. The providers, they are the ones that they use to build the foundation models, right? So they mostly focus on preparing trillions of data. So they have data labelers, an army of data labelers or data editors, and they know the end-to-end life cycle of machine learning because they build deep learning models. Then we have the fine-tuners. The fine-tuners are the ones that they use foundation models and they retrain them, to put it simple. So they need to know about the end-to-end story of machine learning, and they need to be domain experts in order to fine-tune a model. And then we have the consumers. The consumers is the majority right now in the market, and what they do is they just use the models from providers and fine-tuners, and they build applications. So they focus mostly on building applications with the extension of prompt engineering, as we have heard, right? And about RAG technologies like retrieval augmented generation that we will see later on. Now, we have seen in the market also some movements. We have seen providers that they want to build more specific models, and we have seen also that the consumers, they might have reached the limits of RAG, and they want to fine-tune their own model in order to use smaller models, to reduce the cost, etc. Why I'm saying all this? Because the providers and fine-tuners, they need to have an MLOps platform or FMOps platform because they productionize models, while the consumers, they productionize applications. And to make it more clear to you, we will see all the journeys of all these different user types, starting with the consumers, that is the majority of our customers as well. So the consumers, mostly what they need to do is to select first the right model, evaluate the model and start using that as a black box, right? They don't want to care about the, let's say, how I deploy a model, etc. So they want to use an API to trigger existing models. And how do they use these models? They have applications that the end users, they give inputs, they get outputs, and mostly they give the rating. And this rating is very important for us because this is what can help them improve continuously the selection process of the models and the evaluation as well. But how do we select a model? In the market, we have more than 16,000 models, foundation models. I stopped counting them since last year, so I stopped updating this slide for obvious reasons, right? How do we tailor a little bit the list of the models that we can use? The first thing that we ask our customers to do is to select the top 20 models that they have seen in the market that they can help them, and to filter them down based on the key capabilities that the model have and based on their needs. And we will see the key capabilities in the next few slides. After we have now the 20 top models that we can use, in every single use case, we need to select the top 3 models that can resolve this particular use case. So it is not like I'm using one model for all the use cases. Everything should be use case specific. But for this particular use case, we need to have a deep evaluation process in order to make sure that whatever we move into production and whatever we use for our applications, it works and it is robust. So we will see how you can evaluate these models. And the end of the story for one use case is how I select the one single model that I will use. The single model is not just about precision only, it is a combination of precision, latency, and cost, or other business parameters that you might have. So it is really important to think about this and to have human in the loop to achieve that. But let's start now the journey of all these steps and to see how you can build something like that. Key capabilities of the models. First of all, is a model proprietary? Is that open source? Even if it is open source, does it have commercial license? Because you cannot use all the open source models for commercial applications. Is that fine-tunable if I want to fine-tune a model? What about the speed? It is different to build a quick chatbot with millisecond latency than to build an offline system that does summarization. So you need to take care of this. And then we have the number of parameters. The number of parameters is an indication of speed, but also of the accuracy, not always. But for example, I have some customers that they say, oh, I cannot use a model that is less than 30 billion parameters. So we need to know that. And then it is about context window. Context window is one of the most important, and you have seen this in the market, right? Many people, they are talking about this. The larger the context window, it allows you to create, let's say, solutions that they can have large inputs and outputs. This is important not only, let's say I want to generate a book and to generate that, but if you want to do RAG, because we pass the context through the RAG into the context window, you might need also a large one. Of course, the larger the context window might mean more cost for you. And then it's about trained on. What is that? If you want to build an application that generates code, right, you need to know that this foundational model that you are using has been built based on data, the code data. Otherwise, whatever it will generate, most probably it will be rubbish. And then it is about the quality that we will see in the next few slides because it is use case specific. And of course, it is about your skills, right? What do you prefer to use, if you prefer Llama 2 now, Llama 3, or Claude, or etc. Let's see how a reference table looks like. Again, this is an example. This is not updated because we want to show you how to build an example table. And we stopped updating that because you need to have a team to update that every month because every month we have a new model in the market. So one of the most important parameters here is for proprietary, here for open source, is the GPU instance that I need in order to deploy that. This is a good indication for the cost, the minimum GPU instance. Okay. But now we have created the table that the whole business can have a look, can see all the capabilities of the top models in the market, and a new use case arrives. For example, the financial document summarization that I have here. What is the initial process? The initial process, we have prompt engineers or Gen AI developers, might be the same person, and what they start creating, it is a list of prompts for a specific use case that they use in order to test the top models in these 20 models that we have. Okay? So at this stage, with 5 prompts based on our experience, they are really capable in order to bring the top 3 models that they want to use. What I want to introduce here is the notion of prompt catalog. This is something very, very important for LLMOps or FMOps. Prompt catalog is a catalog with all the prompts and example outputs, if you have, right, that we will use later on for an extensive evaluation. Okay? But let's move on a little bit to see how we can evaluate these models. The first and the most important thing is to prepare data. And let's imagine that we already have labeled data. In my previous example, a labeled data example might be like I have a financial document and an example summary, and I have 1,000 of those. Okay. It went black. It is back. So, do we have labeled data of this kind? If we have this type of labeled data, this is great, but because we can use metrics. But what type of metrics can we use? We need first to understand, for this particular use case, do I have a single answer? For example, if I have questions like who is the Prime Minister of the United Kingdom, is Rishi Sunak, right? One answer. In that case, we can use classic machine learning metrics like accuracy, recall, F1 score, etc. If now, in the example of summarization, we don't have exactly one answer, so we need to use more task-specific metrics, like similarity metrics, rouge, blue, cosine similarity, etc. And we have other metrics in the market that are very, very important. Those are like toxicity, semantic robustness, factual knowledge, etc. Now, most of the customers, they don't have labeled data at the beginning of the journey, and this is the biggest problem. How can we evaluate that a model works if we don't have labeled data? We need first to understand how critical is this particular use case. And if it is really, really critical, the first approach is human in the loop. Human in the loop and human evaluators are really important in Gen AI as a whole. The beginning of the journey, we need to have the experts to know what is the right question and what is the right answer for this question. Now, this is a very expensive process, right? Because you have humans, you need to pay them. So what we have seen in the market is we have LLM judges or LLM evaluators, other LLMs that will evaluate the outputs of your own LLMs that you test across the specific use case. And this is something that will come in the market in the next few months very, very, very intensively. But how do we evaluate the models? So we have now this prompt catalog. This prompt catalog might have data, labeled data, as I said earlier, right? Like financial documents, a summary, or a question and answer, or just the input prompts. And what do we do is we pass all these input prompts into the models. The outcome will be, per row, we will have the example output, the LLM output, and the score if we have a metric that we can produce automatically. If we don't have a metric, then more or less what will happen is we will have a score from the evaluators, either human or LLM, 4 out of 5 stars, and a free text to describe the feedback. And we can have prompt testers that they get this initial prompt catalog and they start extending that with massive prompts in order to ensure wide testing. The outcome of this is just aggregated results of all the different accuracy metrics that we have already calculated either automatically or with human in the loop. Then the next step is to decide based on the different categories that I mentioned earlier. not only precision, cost, and latency as well. How do we decide the right one? We know from the here I have an example that we have priority 0, for example, the speed, priority 1, the precision, priority 0, the cost, priority 1, the precision, and speed, we don't care. In that case, from the reference table, we have the speed data. From the evaluation part that I showed you earlier, we have the results. And from the reference table, again, we have the cost part as well. Now, as we can see in this example, Foundation Model 1 has 5 out of 5 in terms of precision, but is the most expensive one. Foundation Model 2 has 4 out of 5, so it performs well, and is the least expensive. In that case, we will go with Foundation Model 2, okay? And this is all about operations. But what do we need to build in order to deliver the solution? We need to have the backend that we already have prompt engineers and Gen AI developers to work on this. Why? Because they selected the right model, they write the prompt, they write this prompt catalog, as I said earlier, where they run the automatic tests and evaluation, and then they need to extend that with prompt chaining or application chaining with guardrails. Guardrails is very, very important topic in LLMOps. What I mean by guardrails? First of all, you cannot get any input to your chatbot, right? If you are a bank and you want to have a chatbot with your customers, nobody can ask questions like, who is the prime minister, right? Because it will trigger your LLM and you will pay more. So somehow you need to have input filtering mechanisms. Also, you need to have mechanisms for harmfulness. You need to see how toxic is the answer of your LLM in order to filter out. Or you need to take care of PII data. So you need to build all these guardrails around your model. And then you need to have a rating mechanism. Why? Because you care about the rating of your end users in order to use that for further evaluation. And we have the front end. The front end is a website that the app devs or DevOps, they create in order to give access to the end users to start using your applications. The end users, the only additional effort that they need to do is to rate their interaction. Why? Because then you can use all this data for evaluation. I insist a lot on evaluation because this will give you the robustness as well. And one more thing about RAG, because we talk a lot about this. In RAG, normally what we have said so far is we have an end user that they interact with a large language model and we get an answer. If we have an example like, give me all the achievements of 2023 based on my financial documents, the LLM is not able to answer the question because it has been trained on other data. So how can we resolve this problem? We need, first of all, to get our data, translate them, chunk them, chop them in smaller parts, translate them to embeddings and store them into a vector database. And then what we do is with the input of the user, we translate this input to another vector based on the same embedding model, and we do a semantic or similarity search to get the context. And then what we do is we pass the context together with the input to the LLM, and we are able to get the output. This is the basic approach of RAG. Many customers, they say, oh, I have implemented that, I have solved all the problems in the world. This is not true. Why? Because here I have some of the considerations when you move to production. Do I have clean data? What is the chunking mechanism or indexing mechanism that I will use? Actually, how can I translate the input query from the user? I don't know. Is the context or the chunks, they come to me in the right order, or I need to re-rank them? And how about the generation? So I need somehow to evaluate the retrieval and the generation part as well. RAGAS is a nice framework if you see that in the market and can solve some of these problems. Some other customers, they want also to use an API to fine-tune a model. I'm not going to stuck into this. We have seen in the market other solutions that through an API and by pushing some data on the cloud, you can start a fine-tuning process to tailor a model. For example, I upload my images and I generate images about Socrates on a motorbike with a sword or whatever example you might have. The only thing is we need to extend the front end to be able to upload the data and the back end to start the fine-tuning. How can we achieve all this stuff so far? By using Amazon Bedrock. Amazon Bedrock gives you access to the key models in the market, so it gives you a small list of this reference table that I said. It allows you to evaluate models through Amazon Bedrock knowledge bases and agents. You can build RAG, and it gives you also access to build your own guardrails with a very easy way. And at the same time, you can also start fine-tuning models by calling an API, and in a very secure manner. But let's see now from Alexandra the journey of fine-tuners and how we can deep dive on this.
Hi everyone, I'm Alexandra and I will lead you through the journey of fine-tuners. Now the first thing you need to consider when you want to fine-tune your models is data labeling. You might need to label hundreds or even thousands of data points to fine-tune your models. Now fine-tuning, this is really nothing else than customizing your model for a specific domain, with a set of different techniques, obviously, that we will discuss in a little bit. Now our fine-tuners, they focus on building these customized models and then deploying them to make them available to different consumers. Now in deployment step, all those concepts we talked about, like prompt engineering and cost versus latency trade-offs, are again relevant for your customized models. And then finally, we want to establish the process of continuous monitoring of your model performance to know if and when you might need to go back to your label data, enhance it, and then repeat the fine-tuning process to keep your model performing at high accuracy levels. So what techniques can we use for fine-tuning? There are two these days in the market, and the first one is called full model fine-tuning. Now here, we focus on retraining all model weights with our custom data. This technique may help you achieve higher model accuracies, but it is also quite computationally demanding and can therefore be also very costly, especially for large foundational models. The second option for you is called parameter efficient fine-tuning, or shortly PEFT. And in this technique, rather than retraining all the model weights, we focus on adding one additional layer on top of our base foundational model. This layer can also be called adapter or delta adapter, and it is much smaller than our base model. So we can load it and unload it from the model and therefore change its behavior. Now you can also have multiple adapters, and all of them can be specialized for different tasks. The key advantage of PEFT is that now you need much less data to fine-tune your model. We're talking about tens of examples rather than hundreds or thousands. It's much less computationally demanding, so it's cheaper and takes you less time to do that. And then, when we think about deployment for both of those methods, for full model fine-tuning, you have to deploy different LLMs to different machines to do different tasks. For PEFT, you can instead deploy one model to a single machine and then have multiple adapters in there because they're much smaller, so it's going to fit. And then depending on the task you want your model to perform, you can dynamically load and unload different adapters and serve different inference requests. As you can imagine, this can be really powerful, as it enables you to significantly reduce the costs associated with your LLM inference. So how can we do these things on AWS? The environment that most data scientists and ML engineers are familiar with is called Amazon SageMaker. With SageMaker Jumpstart, you can access more than 730 public open source models and more than 20 proprietary models. You can also evaluate your models using Amazon SageMaker Clarify with your custom data, with custom metrics for your business, or with accuracy metrics, or even you can introduce human-in-the-loop process for your evaluation. And then you can also customize your models with SageMaker. And here we talk about our fine-tuning process. And SageMaker does support both full model fine-tuning and PEFT. And you can also run this process distributed on multiple machines to reduce the overall time and increase the quality of your artifact. And then finally, you can deploy your models using SageMaker Inference to a selection of different GPUs. Now, all of these steps you can do either through a SageMaker UI or through a SageMaker SDK. Now, another really important feature to mention is called Amazon SageMaker Experiments. And that does allow you to run multiple experiments with a set of different configurations for your fine-tuning processes. You can also compare them and then see which configuration produces the artifact which best suits your business needs. Final step is for us to think how we can automate this entire process. And in SageMaker, you can do this using Amazon SageMaker pipelines. You can really automate the execution of all of these steps and track them in a nice visual workflow. Now today for you, we have prepared a sample project which was built using Amazon SageMaker pipelines, and it is focused on evaluating and fine-tuning LLMs. I will go together through the architecture with you, but you can use a QR code from this slide to access the blog post and the repository code and try this out yourself later. So, in our LLMOps sample lifecycle, the main component or the first component is our SageMaker pipeline focused on fine-tuning and evaluating LLMs. For fine-tuning, our data starts from an S3 bucket, then it goes through SageMaker preprocessing job to prepare the format, and then you use SageMaker training jobs to fine-tune our artifact. Now this customized model we can now compare to different base foundational models that we have selected with Amazon SageMaker Clarify. And you can use any kind of metrics for this that we discussed earlier. You can use metrics for cost or latency. You can evaluate with your custom business metrics. And the output of this should be an artifact that best suits your business needs based on the evaluation criteria you have selected. And that one, you want to register through SageMaker Registry. SageMaker Registry lets you compare different model versions. So for example, version 1 can be Llama 2, version 2 can then be Llama 4, or a different foundational model. Or if it's a fine-tuned model, then you can compare different parameters you use for your fine-tuning process. You then want to improve the model artifact that you want, the version that you want, and the pipeline will pick up the right artifacts for you and deploy them to a SageMaker endpoint. This endpoint we also want to monitor. Now what we monitor in LLMs is a little bit different than standard machine learning because our inference results are not fully deterministic. So we're going to monitor, for example, toxicity. And if this level or this metric reaches above a certain level, we're going to trigger an alarm in our system, which is going to go back to our evaluation pipeline. Now, rerunning our evaluation with entirely same evaluation data doesn't really make much sense. Why? Well, our results wouldn't really change significantly. So what we want to do before that, we want to go back to our data that triggered the alarms, collect that, and enhance our evaluation data set with that data. And now when we run evaluation, we can expect some different outcomes. On the other hand, we have end users that want to communicate back to our deployed endpoint. And between the end users and the endpoint, we have a Lambda function. Now, this Lambda function is responsible for translating user input prompts to a format that our model can understand. As you know, different LLMs require different prompt formatting. In addition, this is also the right place for you to place any guardrails, like, for example, removing PII data from your user input. And you can also introduce any additional context, for example, for RAG documents. The final element of the pipeline is that user can provide also ratings for LLM outputs. And these user ratings, together with the prompt, will be translated and then stored back to our prompt catalog. So we can use them for future evaluations and testings of our system. So our prompt catalog can be enhanced either from end user inputs from one side, or from our data labelers and prompt testers and engineers from the other side. Let's go back to our MLOps foundation. Now, when we think about FMOps instead, we have to make space in our experimentation and model building phase for our fine-tuners. In our data layer, we need to have data labelers that can prepare the data and communicate through a UI with our data layer. And then we have this application layer. And application layer is where our prompt engineers and GenAI developers are actually going to live, and they are the main point between our end users and our deployed LLM. This is also the place where any new model deployments can be triggered from your system. That's it from me. Now you're going to hear how Booking.com has used most of the concepts we talked about today and some aspects of the sample pipeline in their journey to productionalize LLMs for their GenAI use cases. Aaron, the stage is yours.
Thank you, Alex. So I'm Eran. I'm a senior machine learning scientist in Booking. And now I'm going to talk about the summarization use case that we have in Booking and how we use AWS tools to develop summarization models. So first, let me introduce you to Booking. So we are one of the largest online traveling platforms in the world with more than dozens of millions of listings and hundreds of millions of reviews. And we have also dozens of millions of mobile users, which contribute to almost 50% of our bookings. And I belong to a unit that is called Central Machine Learning. and in a team that is called Content Intelligence, that we own several capabilities. We own image processing capabilities, such as image captioning, image classification, and moderation. We own also textual understanding capabilities, such as text-to-topic and sentiment analysis, and also moderation. We also own the AI tree planner that you might heard of, which is our chatbot that we lately launched, which is GenAI-powered chatbot that can recommend you about hotels and destinations and attractions. And the last piece is the text generation that includes machine translation, summarization, and GenAI for content. And today I'll talk mainly on the summarization capability. So I'll talk about two main use cases that we have, but we have much more summarization use cases. So the first use case that we started developing is a summarization of user-generated reviews. So as you might know, a lot of properties, they can have thousands and even dozens of thousands of reviews. And we want to give some, short snippet of a summary of all the reviews with up to 3 positive bullet points and 1 negative. The second use case is property description, that we aim to take the full description that might be, let's say, 5 paragraphs about the property, and we want to generate 1 paragraph short summary about the property with up to 235 characters. So our general strategy is moving from one general description to personalized description. We start by taking a property description, then insert it into a summarization model, which we fine-tune ourselves, as you might see in a few seconds, and we output general summary. The main advantage of this approach is that it doesn't require any personalized data to train. We use data that our content experts generate for us, and it allows us to achieve low latency because we do it on a daily basis. We generate the summaries on a daily basis and store them, and then we just serve them in production based on our database. But the disadvantage of this approach is that it's not personalized to users. The second step, we aim also to insert into the model the traveler type, which can be, for example, solo travelers or couples. This will also allow us to get some personalization in the summaries with still low latency, because we are going to do it for every property on a daily basis. We're going to generate summaries for all traveler types, which are limited, and we are going to serve it in production. But we need to collect data for that purpose. So we first need to go through the first step, collect some data from users' feedback, and then to start developing this one. Eventually, what we want to achieve is fully personalized summaries, which are going to be based on the user preferences. So let's say if I filtered, for example, for hotels with swimming pools, so we might want to show the user that the property really has a swimming pool in the summaries and take it into account. So we aim to achieve high level of personalization within the summaries, but it's going to be very challenging for us because we need to serve it in production, and we aim to generate these summaries online with extra low latency. So I'd like to show you what was the implementation journey that we made so far, and then I'll also talk about our future plans. So we started by creating some initial summaries using foundational models. How we do that? So we have all the property descriptions stored in Hadoop tables. We created a small data sample and put it in Amazon S3. And we took several foundational models and we deployed them to SageMaker endpoints using notebook instances. And we worked with our product teams and content teams to review them and do some eyeball testing to see which model seems the most promising for us. Then we asked our content team to take the sample that we generated and to take all the summaries there and rewrite them, okay? In order so they can meet all booking guidelines and all project requirements, for example, about the length. So here you can see, for example, the original property description. Then we had the pre-trained LLM summary. And eventually, you have the corrected summary, which was corrected by human to meet all booking guidelines for the summaries. Then, after collecting a few hundreds of summaries, So we created an infrastructure to fine-tune our models. So the infrastructure, we store our data in Amazon S3, and then the scientist needs to define a recipe, which the recipe includes what are the data arguments, what are the model arguments, what are the training arguments, and then we can launch a training job that does all the fine-tune process based on Hugging Face models with our unique LLM evaluation code. And finally, it outputs logs that are stored in Amazon CloudWatch. It also outputs our metrics, our evaluation metrics, and some evaluation artifacts in weights and biases, so we can compare between the models and the different experiments that we did. And eventually, it stores the model artifacts in S3, so we can later deploy the best performing model. After doing that, we found out that the automatic metrics that we extracted are not fully correlated with quality. So we worked with the content team to define another human-in-the-loop process that we bring the summaries that were generated by one of the models, and we ask them to rate them according to several criteria. The criteria are language accuracy. We ask them to search for typos, for punctuation issues, and things like that. Clarity and readability, how clear is the summary. Brand, which includes also the editorial style and the tone of voice. The use case, in which we ask them to say how relevant is the summary and to say if there are any repetitions, because we want the summary to be as dense as possible and not to repeat on the same information multiple times. Then we have the project style requirements, which relates to the character count limit, and the project content needs, which they evaluate if the summary has some hallucination in it. So then came out DPO paper that allows us to fine-tune, to do another fine-tune step based on the previous step, that we can say for the same property description, given that we have two summaries, we know which summary has a higher quality. We can fine-tune the model based on that to make the language model generate summaries which are more similar to the winner summary and less similar to the losing summary. Eventually, we created an infrastructure to deploy the model so we can run it on a daily basis over all of our properties. We have around 3 million properties that we generate summaries for. And the process is like that. We have the Airflow pipeline that is scheduled on a daily basis that starts by deploying the SageMaker endpoints, the best model that we generated. Then we have a PySpark script that reads the data from our Hadoop tables, the property descriptions. Then it calls the model with multiple concurrent processes, and finally stores the inference results in another table. Eventually, we delete the endpoints to make all the process as efficient as can be. We also tried different configurations for deployment, for model deployment here. We tried TGI, and LMI, and VLLM, and found out TGI to be the most efficient for our use case. So in the next few days, we're going to launch an experiment for properties in the US region that will show the users that are going to be assigned to the control, the current description, as you can see on the left side, and on the right side, you can see the treatment. You can see that the users that are assigned to the treatment will get the summaries for the properties, and then they can read more. And when they read more, they can see the summary that we generated, as well as the full description. In addition, we allow them to click also on helpful and not helpful button. So we collect some user feedback that we can later use to create better summaries and personalized summaries. So all of our efforts resulted in an increase of the quality by 16%, which was amazing for us because otherwise we couldn't move to production. And also using all the optimizations that we did to deploy the model could reach a reduce of 6 times in the cost and increase of 8 times in the throughput, which was also amazing for us because the meaning of it was hundreds of thousands of dollars a year. So looking ahead, so we aim, as I said, to move over time to personalize summaries by doing it in 2 steps. The first step, we will do it on the traveler type level and do it on still on a daily basis. And finally, we aim to use the all user context and all search preferences that the user provides to generate a summary that is personalized as we can, the best personalization we can do for the summary. And we aim to deploy it and to generate summaries in online manner. Now let's Socrates to wrap up the session.
Thank you, Ran, very much for the presentation. You saw already Booking.com is a fine-tuner, right? They use a lot of human in the loop to evaluate the process. Where we want to conclude, depending on your needs, depending on what user type you are, we have different services that you can use in order to productionize GenAI applications or even to productionize your own models. For example, if you are a consumer, we have Bedrock. If you are fine-tuner, we have SageMaker. If you are a user at the beginning of the journey, you can use Amazon Q that we didn't cover today. Some very important links for you here. I will leave this slide a little bit more just for you to get some pictures. The first one is Generative AI for Builder workshop that you can see all the GenAI service that we have on SageMaker step by step, and we explain you the journey that you need to take in order to perform all the different tasks. The second and the third are 2 blog posts that helps you to understand the end-to-end life cycle and what Alexandra also showed you earlier, while the last one is another blog post that all these blog posts are bound with GitHub repositories, right, for code for you. So the last one shows you how you can capture metadata about which team is using what model and what is the cost per team. So it is very, very important if you want to use, for example, Bedrock and different teams focusing on different models. We would like to thank you. If you want to connect with us, feel free to connect with us through social media, and please feel free to give us feedback about this session. Thank you very much.